Hello, hello. It is day 2 of online learning, and you guys are doing an excellent job so far, so please keep it up. Before we go over our math morning work, I'm going to share a subtraction with regrouping vocabulary video, and then we're going to jump into our math morning work and go over the work and the answers for it. Okay?
Hey, it's your boy Mini Who coming live just to help you with subtracting and regrouping. It's a problem that we all have to deal with. Sometimes you're faced with a question where you have to borrow a number and you have to figure out where that number comes from to find your answer. So if you're ready for it, sit back and relax, and borrow that number. When subtracting large numbers and the digit on top is smaller than the digit at the bottom, we got to borrow that number. Borrow that number, borrow that number. Borrow that number from the next place over. Repeat this till it's over, because regrouping isn't hard when you can bring it over. So, borrow that number. Borrow that number, borrow that number. Borrow that number. I have a friend named Robin. He loves to stack his coins. He loves to give. He's generous. He loves to share his coins to all his friends and family. It gives him massive joy. When he opens up his pouch, he has a large amount. 745 golden coins that he counts. One day, early morning, took his coins and gave out 358 coins out his pouch. How many coins are left? Let's just follow these steps. Take the number that he started with, subtract it from the number that he gave away, subtracting right to left. 5 minus 8, that's no mistake. We have to take the 5, make it bigger to subtract the 8. The next place over has a 10 that we can borrow. At first it made me hesitant, like seeing scary shadows, but think about it, it makes more sense if we think in tens. We take the 10 from our 4, give it to the 5. We have a 15 in the ones and a 3 in tens. 15 minus 8, that gives us 7, that's in the ones place. But in the tens place, we have 3 minus 5. We have to borrow from the hundreds place. 1 unit of 100 is equal to 10 tens. 6 is in the hundreds and 13 in the tens. 13 minus 5 is 8 in the end. Now in the hundreds place, we have 6 minus 3. Let me think, so our answer is 3. 387 coins is what he has now, after passing out over 300 coins to his town. Robin is an awesome leader. When he walks into town, he's surrounded by crowds. He makes us all very proud. When subtracting large numbers and the digit on top is smaller than the digit at the bottom, we got to borrow that number. Borrow that number, borrow that number. Borrow that number from the next place over. Repeat this till it's over, because regrouping isn't hard when you can bring it over. So, borrow that number. Borrow that number, borrow that number. Borrow that number. We don't have to use a chart to subtract. You just have to make sure your place values all match. 317 minus 68. We don't have to wait. Let's start in the ones place with 7 minus 8. We borrow 1 from the tens place. It gives us 17. It leaves us with a 0 in the tens place. You see, we proceed. 17 minus 8 gives us 9. 0 minus 6, I can promise we'll be fine. If we borrow 100 from a 3, it becomes 2. Subtraction is the next move. Turn 0 into a 10. Now it's 10 minus 6. Then we're left with 4. 2 minus 0 is 2, I'm very sure. Our answer is 249. But let's check our answer just in case we're misaligned. We can take the smaller number, add it to the answer. We'll get a larger number, which will verify our answer. 9 plus 8 will give us 17. Drop down the 7 and carry the 1 into the tens place. But no, we're not done. 4 plus 6 plus 1 is 11. Carry the 1 to the 2 that is present. Now we have 3, which proves the connection between the two answers. No need for corrections. 317 is proof that we did it. Yeah.
All right, hope you enjoyed that video. Now we're gonna jump into our bell work. Today's bell work was the Daily Common Core Review 15.1. First question, which equation shows the commutative order property of multiplication? Now, when we think about the commutative property, we're thinking about two numbers that are flipped in multiplication that equal each other with the equal sign in the middle of it. So A does not represent that because it's 3 times 2 times 4 equals 3 times 8. Now, what we're looking for is two facts on one side and two facts on the other side. They're multiplied together and they equal each other. The equal sign represents that. So that's not A. And then we take a look at B, 6 times 1 equals 6. Although that is a fact, we're looking for the commutative property of multiplication, and that is not representing that. We need two facts on one side multiplied together and two facts on the other side multiplied together, and they have to equal each other. Same thing for 5 times 0 equals 0. We need to make sure it represents the commutative property of multiplication. Two facts on one side multiplied together equals two facts on the other side multiplied together, and they're flipped. So when we take a look at D, we have 5 times 2 equals 2 times 5, and that represents the commutative order property of multiplication because we have 5 times 2 on one side, and then it flips, and then it's 2 times 5 on the other side. They equal each other because 5 times 2 and 2 times 5 equals 10. Okay, now we're moving along. Number 2 says there are 2 rows of socks in Kylie's drawer. Each row has 4 pairs of socks. Which equation shows the number of individual socks in Kylie's drawer? Now, when we think about an equation that represents individual socks in Kylie's drawer, we have to go back into our word problem and use the information that was given to us. We have 2 rows of socks, so we're definitely going to have two down. Then we have each row has 4 pairs. So we know that we're going to do 2 times 4. That keyword each is in there, 2 times 4, not just 2 times 4 because we have pairs. Pairs represents 2 of something. So now we have 3 numbers in our equation to show the number of individual socks in Kylie's drawer, and that is 2 times 4 times 2. Now that we've solved that, we're going to go down into our options. Which one of those is 2 times 4 times 2? And that is D. 2 times 4 times 2 equals 16. So D is our correct answer. Okay, moving to number 3. It says Sloan has to pick her father up from the train station at 6:45 p.m. It takes her 10 minutes to get ready, 10 minutes to get fuel, and 50 minutes to drive to the train station. What time should Sloan start getting ready? Now, when we think about elapsed time, we are going to make sure we count the hours and count the minutes. So we need to backtrack because it says what time should Sloan start getting ready? And she needs to arrive at the station at 6:45. So we need to go back 10 minutes because she has to get ready. We have to go back 10 minutes to get fuel. And then we have to go back 50 minutes that she needs to drive to the train station. And then we're going to figure out what the starting time is that she's going to get ready. Okay? Now, in completing this problem with elapsed time, the first thing we need to do is put down our start time. And that's exactly what I did on my whiteboard. I put down 6:45. That's what you should have done on a piece of paper or on the side of your paper on your morning work. Now, if I need to figure out what time Sloan should start getting ready, that means I need to go back the 10, the 10, the 50. So the first thing I'm going to do is I'm going to subtract 10 minutes. So 6:45 minus the 10 minutes, and we know that we get 35. So now we're at 6:35. We still have to go back another 10 minutes for her to get fuel, and we still need to go back another 50 minutes for her to drive to the train station. So I'm going to erase my board so I can have some room. Okay, now we're at 6:35. So we need to subtract 6:35 minus the 10 minutes. And once you do that, you should have gotten 6:25. Now we don't stop there because we still need to go back another 50 minutes. So when you go back another 50 minutes, you already know that the answer choice wouldn't be D. That's a process of elimination here. That's a strategy. 6:25 would be out because we are already at 6:25 and we only subtracted 20 minutes and we still need to go back another 50. Okay, it wouldn't be A because we wouldn't go back that far in time. Now, when we subtract 6:25 minus 50 minutes, we should have gotten B, 5:35 p.m. Okay, that's how you solve that. You just keep going back, right? Now the next question, which fraction is equivalent to 4/8? Now with me, I have a fraction strip to show you if you need to remember some equivalent fractions. And on here, I have circled 4 of the 1/8, representing 4/8. And when I go straight up into this section, I've already drawn my line down the middle of my fraction strip like we've done before. I need to figure out which fraction is equivalent to 4/8. Okay, so when I take a look at 1/4, which is A, that first option, that's only 1 of the fourths. That is not equivalent to 4/8. Okay, so A is out. Then I take a look at the next one, option B, 2/6. So I need to circle 2 of the 1/6 on my fraction strip. Is 2/6 equal to 4/8? Nope, they do not match up. Okay, so it's not B. Right, let's take a look at C. We have 1/2. Now I'm highlighting where 1/2 is. We know that 1/2 is at the top of our fraction strip. Does 1/2 match up with 4/8? Yes. So our answer is C, 1/2. So which fraction is equivalent to 4/8? The answer is C, 1/2, right? Let's see, let's move along here. Next question, it says, Nori has 15 raisins. He wants to put them in groups with the same number of raisins in each group. List different groups of raisins Nori can make. Now, I'm sure you easily figured out that when it's talking about groups, it's asking for 2 facts that would equal 15. Now, if it's asking for the same amount of groups, that means we need to have as many as possible facts that we can get to equal 15, okay? So one thing that we can do is 1 times 15 equals 15. And I'm sure you would agree. So that would be one group of 15 raisins. So you could have written one group of 15 raisins, okay? Written out, one group of 15 raisins. Now, another way to write 1 times 15 is just simply flipping it. 15 times 1 equals 15 groups of 1 raisin. Okay, so that's another way. You could have done 1 times 15. You could have done 15 times 1. 15 groups of 1 raisin, or 1 group of 15 raisins, or you could have done 3 times 5 or 5 times 3 with that same key phrase, groups and raisins, okay? Right, let's see. Moving on to the next one, number 6. It says Gila Cliff Dwellings National Monument has an area of 533 acres. Oregon Caves National Monument has an area of 488 acres. About how many acres larger is Gila Cliff Dwellings than Oregon Caves, okay? Now, we have to think about the information that we need. And the first thing that we're going to do is we are simply going to subtract, because it says about how many acres larger is Gila Cliff Dwellings than Oregon Caves. And we know that than is a key word for something, comparing. Now, when we're comparing, we're going to do subtraction. That's a key word that we keep in the back of our mind. So we're going to do 533 minus 488. Okay. Now, I have lined mine up, and I'm hoping that you did too on the side of your paper or on a piece of paper if you have it. So clearly we cannot do 3 minus 8. So what has to happen? We need to make it a 13. Okay? Now, if we do something on the left, we have to continue on down to the middle. Okay? We cannot do 3 minus 8 once again. So we're going to make this a 12. Okay? Now, clearly if we do something in the middle and we take away 1, then we simply need to keep going, and this 5 becomes a 4, okay? So now we have 13 minus 8. 13 minus 8 equals 5, all right? Then we're gonna move to the next one. 12 minus 8 equals 4, okay? So now I'm at 45 so far. And then we have 4 minus 4, which equals 0. So if you wrote 45, I'll take it. If you also wrote about 40 acres and you answer that about question, then I will take that as well, because those are both correct answers, okay? But I mainly want us to get to understand how to do subtraction with regrouping and remembering those steps, okay? Number 7 says, which of the following measurements is not reasonable for the capacity of a water pitcher? Explain. Now, Let's see. The options that they gave us was 500 milliliters, 500 liters, 1 liter, 3 liters, and 1,000 milliliters. Now remember, when we're thinking about liters and milliliters, milliliters are small amounts of liquid and liters are large amounts of liquid, okay? Now with me, I have a picture right here. Do we think this would be 500 liters? So taking a look at your options, do we think this would be 500 liters? That's a lot. I think that wouldn't be unreasonable, right? Because if we take a look at 500 milliliters, that's small amounts of liquid, so that could be reasonable. If we say 1 liter, that could be reasonable. If we say 3 liters, okay. If we say 1,000 milliliters, milliliters are still small amounts of liquid. So this definitely wouldn't be 500 liters, okay? Right? And your explanation should be centered around the idea of what milliliters are and what liters are, and comparing the difference between the two, okay? And thinking about a picture right here. All right, now we're moving to number 8. It says Reggie's bedroom is 10 feet long and 8 feet wide. What is the area? Now with area, we do length times width to figure out our area. So first thing we're gonna do is we're gonna use 10 feet long, okay? 10 feet long times 8 feet wide, so length times width. Right. So 10 feet long, 8 feet wide, 10 times 8, length times width, 10 times 8 equals 80. Now, it's not just 80 because we're using area. So it should be 80, what did they use in the problem? And then square it. So they use feet, so we're gonna square the feet. So it should be 80 square feet. Okay. All right, and that concludes our bell work for today.